When we cluster the portal, we have several options or several aspects that we need to pay attention to. One, and well, I would say one of the most important aspects, is the communication between the different cluster machines, the cluster nodes. We've mentioned the caching or the caches that Liferay has within itself. There's always some cache that prevents Liferay from needing to go to the database to look for everything, for every single request. Especially the most frequently requested content will always be served from memory. But if you update this content on one of the nodes, you want that update to have an effect on the other machine. And that means we'll need to invalidate the caches of all cluster machines. And that's precisely what we're discussing in this chapter. Each node will talk to each other node in the cluster. That's necessary in order to give each other a note that some content has changed. With the database server, whenever we change something in the database server, then we'll need to make everybody aware. If we didn't have this notion, then we wouldn't have a proper cluster. In fact, whenever I get called to somebody who says, hey, this machine doesn't really work, and I'm changing data, but it doesn't reflect on the user interface, it's typically this component. I can't count how often I've told people, customers, on the forum, users that have asked, I can't count how often I've told them, you didn't do clustering right. And quite often the answer was, well, yes, the cluster works. It's only that the content doesn't update. The answer is, well, then your cluster doesn't work by definition. So it's not properly configured. So we'll need to send these messages to each other to other nodes, and we're going to discuss how that works. The keyword here in Liferay is cluster link. Cluster link is the component that we use that will communicate messages on, for example, Liferay's message bus, as well as the caching invalidation. It says here the communication is done by combining two technologies, Liferay's message bus and multicast networking. If you are alarmed by this because multicast is allowed, stay calm. We can work around multicasting. In fact, we can totally disable it. With cluster link and multicast, you'll have the most comfortable setup because Liferay instances will just find each other if they're on the same network with multicast enabled, and everything is fine. You'll just need to fire them up and they will see each other done. If you don't have multicast, you'll need to introduce them to each other manually. That's then your own duty, so to say. Liferay's message bus is the component that helps us, well, keep track of messages, of anything that needs to be executed asynchronously, not in sync with the HTTP request. And these messages can be distributed in the cluster. They can be just within the same machine. And actually, cluster machines will elect a cluster master, and you can schedule some messages to just be executed on the master, and that's why we cover message bus here. Message bus is a component that you can also use in your own plugins. However, that's all development, that's not part of DevOps. Still, we gotta be aware that there is a message bus and that it is also part of the whole cluster link communication. Now, when I say cluster link is powered by multicast networking, I've already mentioned it, multicast means it's very comfortable to discover each other, and it should work in your local Docker setup, but it typically doesn't work when you have any kind of cloud deployment. So when you are running in the cloud, then you'll need to configure the nodes or the cluster link communication explicitly or through other means than multicast. It just doesn't work to discover each other. If you have multicast, then, as I said, it's the most comfortable solution. You just fire up different cluster nodes in the same network. They will broadcast a message, they will listen to that message, and they will discover each other and just connect and say, well, I have a new message here, some content was updated, and you should please update it yourself as well. That is nice if this one network that you host contains exactly one category of Liferay instances. If you host your test systems, your user acceptance test, your development, and your production systems in one single network, then they will all find each other and will invalidate each other's caches. Currently, I'm not really aware if there's anything really bad that could happen, but I also wouldn't say, I wouldn't give a guarantee for that. One of the cases is you'll just invalidate caches even though it's not necessary, which means you want to avoid this kind of a setup. You want one network to just see the same category of Liferay nodes. Now that I told you that cluster link is a very important component in Liferay clustering, how do you enable it? Well, spoiler alert, it's here. It's very simple. We'll need it very early in the process. So it is a configuration that goes into Portal ext properties, and the configuration is cluster.link.enabled equals true. Bing, done. Magic. Well, the magic is done by multicast. If you just enable this, you're running on multicast and everything is fine. If they see each other, discover each other, and then start sending messages to the group. That works quite well in our local Docker installation. You can actually see it when you just observe the logs while you start up your system. Just use Docker compose up without the -d. So don't start it as daemon, but keep it in the foreground, and then you'll see the log. And when you see one node starting up, and then you fire up the other node, you will see the messages that get exchanged between the two, and you will immediately be able to recognize, hey, clustering works, or cluster link works, they have found each other, and they are now communicating to each other. It's a very easy check if everything works. If you have a situation where you are sharing one network with multiple instances of Liferay, with multiple installations of Liferay, your test environment, your production environment, or just multiple development environments that shouldn't interfere with each other, then you have some multicast properties that you find in Portal properties that you can also set in Portal ext properties. That's the default ports in the multicast communication that get used, the messages, so that you will be able to separate all of your systems from each other without enabling Unicast mandatory. Here are the settings. You can determine on which of the network adapters you will communicate, the bind address, bind port, and then the group address and the group port. This is what all the machines should share or must share if they should communicate with each other. So configure that for every single network, for every single cluster that you configure separately, and you'll be good to go. We have a couple of cluster link channels here. We have a control channel and a transport channel. To be honest, I haven't ever configured them, but there are some settings that you find in the documentation, especially in Portal properties, because this is a part of Portal properties where it gives you some hints on how to configure them if you are in the rare situation that you gotta go through here. And remember, your homework is anyways to one day go through, browse through Portal properties, through the original file, and there you will discover that there is a bunch more than we could ever cover in any training. Speaking about cache and invalidation, this is not precisely what we need for clustering, but while we are at cache, at discussing cache, we might as well discuss the different layers of cache that we have. For one, Liferay has a very low-level database cache, and then there are a couple of, actually two kinds of caches on top of that, which contains business objects. And these business objects are exactly what needs to be invalidated, or at least some of them. We have a so-called multi-VM cache and a single VM cache. Single VM cache is the easiest. We don't care if those get out of sync, because it's been fired by some external resources. Let's say the weather forecast that you get on one of these nodes. If the weather forecast is out of sync by 5 or 10 minutes between the machines, it doesn't change dramatically for each individual region. That we don't care. We'll just keep this cache local on one machine, and if the other machine needs it as well, then it fetches it from any kind of external resource, and we don't invalidate anything. With articles, with images, with content that you upload to Liferay into Liferay's database or document library, this is different. If you edit an article and if you edit news on one machine, you want to see that immediately on all of the other connected nodes as well. And that's what we call the multi-VM cache, which is on the business level or business layer. This is what we really need to take care of, what really needs to be invalidated. I'm saying invalidation because I quite often hear the word cache synchronization or cache replication, which is not what we do. Think of just two caches. I'll just go with my two hens, two nodes, and you'll have a particular object that you change on one server. Now, as soon as you change this object on this server, the cache invalidation message will be sent across the cluster. So in case you have this object cached on any other node, it will be forgotten, just removed from cache. That's it. And anytime somebody else requests the same object with the same ID from the second server, it will be fetched from the database. And then it's current. The important part is just, if you have a cache of this object, drop it. And any subsequent request will fetch the current object from the database. And we're done. That's what we need. We don't need to actively say, hey, here's a new object, keep this in your cache, because that would actually hurt scalability. Maybe nobody ever requests this object. And if they do, we're quicker, or we're good to just get it from the database anyways. You can override some cache settings. This is not precisely what we need in DevOps right now, but as we are talking about the caches, here are some locations or some files where you can configure it. The files are somewhere these actual files are somewhere within Liferay's jars, but you can change them, you can extract them, you can configure them, for example, to change the cache sizes, which are defaulted somewhere in these files. And then you can make these files available to Liferay and configure a new location for them, which means you can change cache sizes easily. But it's not part of clustering Liferay, it's just because we're covering caches right now. These are some configuration values that are related. We don't need them, we don't touch them in this training. I just want you to be aware. If you have a content-heavy site, where you say there's a lot of articles and they constantly expire from the cache because too many articles are requested at the same time, you can increase the number of cached journal articles or decrease the number of user objects if you have only a few users, for example. We have a scheduler, and this is more news for anybody of you who is watching this course but is actually operating an older version of Liferay. Definitely the 6.x versions. I'm not quite sure if it's still the 7.0 versions as well. Definitely not the 7.1 version. We have a scheduler in Liferay. And once you have a scheduler, you for sure don't want scheduled messages to be executed at the same time on every single cluster node. So the scheduler must be cluster aware. The scheduler should take care of these scheduled events just to be fired on a single node. Now the good news And that's why I say this is not interesting for you who are sitting in this course or who are watching this course. For 7.2, the scheduler is cluster aware by default. In older versions, you got to make sure that it is. There's just a single setting that you got to set. And then the the Quartz engine will be cluster aware. In the very old systems, you had to drop some related cluster scheduler tables from the database because all of the scheduling is saved in the database, and the Quartz tables differ in cluster mode versus just single node mode. But for 7.2, you got to be aware, the scheduler must be cluster aware, but you don't have anything to do because it is, unless you choose to make it different, to choose a different communication. And that's precisely what we have here. Once cluster link is enabled in Portal X properties, everything is handled behind the scenes. It actually really makes sense because, hey, we'll say we want to communicate in the cluster, but we don't care about the scheduler. No, actually, as soon as you want to communicate in the cluster, you want to communicate in the cluster with everything. So it really makes sense that this is automated. If you really want to communicate in Unicast, you can do so. And as I said, when you deploy on the cloud, you definitely need to. You gotta make these individual machines aware of each other. When you can't use multicast, or when you just don't want to use multicast, or when you're not allowed to use multicast for policy reasons, then you can configure multicast, and we will do so. We can change the settings again in Portal ext properties. We're doing this in Portal X properties because it's a very early setting. It's also an old setting that is there forever. So it was in Portal X properties forever, and it's a very early setting, just as the database connection. So we have it, and we don't expect it to change over the runtime of your server anyways. So you're either running in this cluster or you're not running in this cluster, and if you're not running in the cluster anymore, then you might as well restart. I mean, the cluster might go down to just a single node, but you still want to run in a clustered environment. If the second node gets added, then you want it to be added again. If you want to change your cluster setup and say, I'm continuing on a single machine, then you'll have to restart. Configuring for Unicast means you gotta choose one of the Unicast methods, and for example, we have a TCP ping there. Ping is basically the discovery protocol in this case, so where you'll have to give the Unicast addresses, where you'll have to discover them all, and you have to have a list of all of the cluster members by either host name, by IP address, and by port number. So in your configuration, you'll have to say, when you're looking for somebody else for this cluster, look at this address, and this address, and this address, and this address, and this port. On multicast, you just add another machine and they will find each other. Unicast, you better be prepared. If you want to configure Unicast the way that we mention here with a TCP node and XML, just look at the documentation. We don't cover it in depth in this course. Just look at the documentation and you'll find the Unicast setting there. It involves having an XML file, making that available to the Liferay class path in the core, and then it is just working out of the box. But out of the box means it's working with every single machine that you made the cluster aware of. So you'll have to determine these are all the machines I ever want to add to the cluster and nobody else, because there is no automatic discovery anymore as soon as you configure it.